Okay, so OSI layer from the perspective of cybersecurity or network security. So let's head over to the next slide, which is talking about every layer and what kind of securities we can come across. Okay, so we already know. So I will. I'm going to start from the layer one, which is physical layer. We already know the physical layer of the OSI model is responsible for converting data packets from the data link layer, layer 2, into electrical signals, and we have already talked about bits and bytes. Okay, so keeping data safe at the physical security layer allow unauthorized access and restricting access to critical servers. Security in the OSI physical layer comprises the enterprise's physical and site security concern, which includes all these aspects like access control, power management, environment management, smoke and fire suppression, backups, protections of the physical layer infrastructure. So when it comes to the physical layers security, the most important thing we need to keep it in mind is the access. And I'm going to give you my personal experience over here. I had one security IT room, not security, but IT room, which has many servers, and we call it data center, a mini data center. Okay. Then we have patch panels, we have some telephonic kind of uh, switches, okay, which has tons and tons of cables that go to other departments or the offices or the floors. Since I'm engaged with the hotel IT management or a hotel IT services, that's why we usually dealing with the floors, okay. So sometime what happens, and it has happened on so many occasions, that I have this IT room and I forgot to lock my IT room, and I went for the inspection, or maybe I went outside for a lunch. Then in my absence, what happened? Some housekeeping personals, they comes to my IT room. They usually knock the door. If I'm available, I will open the door. If I'm not, they try to open the door. Okay. So what happens? I have some CCTV cams installed in my IT rooms. Multiple CCTV LEDs that having the visuals of every floor, reception, and all these blah 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 things. Okay, so these sweepers, they come into my office, and by the way, every person has the habit to put their hands on top of some switch or something, like just to stabilize your leg, okay, something like that, to give a rest, something like that. So they are sitting and they want to rest their leg, and basically they are putting their legs on top of this switch, this telephone switch, which has very thin cables. So what they do, they end up maybe yanking out those cables. Okay, end up maybe this cable is going some floor's room where this phone is installed, and it is not working because this guy yanked out that cable, and he will leave. Once I will come back and I will sit on my chair, I will start receiving the calls from the reception. The room number 801 phone is not working. So I will go over there. I will check the phone, and phone is totally dead. Then I will attach some device on that um, hotel room. On the other end, I will try to track down that cable first of all. And I will show you in one slide that what kind of devices you can use to troubleshoot what. I will come over here. I will check with that buzzer tool where this cable is heading to, and I will check that cable is unplugged. So that, the whole scenario, or you know, uh, the scene, what I'm trying to um, make you realize over here, that physical security is one of the very, very, very important aspect. So from that day, really, I always locked my door. so nobody could enter in that room. So physical security is very important aspect. Similarly, you need to make sure your power management is working fine. You have smoking and fire suppression devices installed. You must have backups like we have UPS, universal power supplies. In case of power outage, you should have UPS in place. Then physical layer infrastructure, like on each floor we have these switches installed from where these cables go to every room. Okay, so if somebody come and unplug this device, I don't have any option, to figure out unless I will go reach and check that switch. So you have these cabins, you need to lock those cabins as well with a key. Okay, and similarly you have wireless access points over there as well. So you have to somehow protect those devices accordingly. Then we have data link layer, and we know that at data link layer we have switches. So as I said, first of all, we need physical security. We need to secure these switches wherever they are. Then, as from the paragraph, it is saying that data link layer is a primarily concerned with the physical addressing, line discipline, network topology, error notification, order delivery of frames, and flow control. So it means it could have these kind of issues. Error notifications, order delivery, flow control, frame issues. Okay. So devices such as switches and bridges work at this level. Understand the security threat that may occur at this level and how to mitigate. Some of these threats are like ARP spoofing. And by the way, when we will hit the network security program or the module, I will be talking about a lot in detail. But here I'm just going to scratch the surface. So we have some ARP spoofing, we have MAC flooding, we have spanning tree protocol. So if I will just take one example of MAC flooding. So basically the switch keeps the table of MAC address. So it will be having the table of MAC address, which basically is saying I have multiple ports on my switch like 1, 2, 3, 4, 5. 1, 2, 3, 4. On the first port, which MAC address or computer is connected? So this computer will be having some MAC address. This PC1 will having the MAC address of that computer in that switch. Similarly, on maybe second port, the router is connected and router has its own MAC address. So router MAC. Similarly on third and fourth. So this is how switches will keep the information uh, or correlate port with the MAC address. So what happens in a MAC flooding? This table has some capacity. This table has some capacity to keep information about MAC addresses. Let's suppose this switches can contain 1000 MAC address information stored inside the table. MAC flooding, what hackers do, they will flood ton and ton of MAC addresses, end up choking this table because it can only facilitate 1000 MAC address. But imagine if we have more than 1000 MAC addresses, what switch is going to do? It is going to bombard everything everywhere. Okay. So this switch will become a hub, a dumb device. So this is how hackers what will do. They will take a notice of every packet, because after that whoever is going to send the packet will be destined to everywhere. Everywhere means the hacker may be sitting on this device, and the hacker can get all the information about that PC what is the MAC address, what is the IP address, what is means all details, nitty gritty details, and with the help of the detail, he still can, um, you know, dig up whatever the information he or she want to. Okay. Similarly, we have span tree attack. So these kind of attacks happened at data link layer. So you have to look out on this. Let's head over to the next slide, which is talking about the network layer. At this layer, there are many protocols, IP, responsible for routing, and we have already talked about routing of data and network information. It is important to understand how attackers could misuse of any of these protocols and gain access or spoof any network. Lots of security attacks that can happen here include denial of services that packet sniffing, just like we are doing using Wireshark. All the Wireshark we are using for the positive purpose, but it can be used negatively as well. Okay, because it is giving me all information. So what hackers do, they can install some tapping device in between. Tapping device is just like a star kind of device. From here, this is going to destination. This is the source. And maybe the hacker is sitting in between with the Wireshark installed. So whatever the communication is going through this wire, this person or the this hacker is having a hands on to those all information, and he can extract the information. Denial of services. Basically, for example, we have job skill share website. And let's see, this website just can accommodate 1000 simultaneous access. So what attackers do, they can send so many TCP sync. And we are going to cover TCP a lot in detail next module. But they are going to send so many TCP sync attacks at once in a fraction of a millisecond that go beyond, maybe I don't know what this figure is, but something like that. End up choking this server. It cannot provide its services to the users, to the end users. Maybe you are studying some topics on that job skill share, but unfortunately, if somebody uh, launch DOS attacks on this website, you will not be able to access those services. So this is the main idea behind having DOS attacks. Similarly, we have ICMP ping of deaths that works in the same DOS attack fashion. Then we have IP address spoofing, route index, backhaul, and selective forwarding attack. That all comes under network layer attacks. Okay, so if you are interested, you can go one by one and you can take a look and read out what routing attacks are, what IP address spoofing is, what is ping of death. Under layer 4, which is talking about the transport layer, and transport layer, we know that transportation of a data using either TCP or UDP. So this is where the TCP protocol resides. To understand the security issues relating to the TCP or UDP protocol suite essential to cybersecurity. Some security threats that occur at these levels include the following: endpoint identification. By the way, this is not a uh, some attack. This is the mitigation. So endpoint identification, this is installed on your endpoint system to identify what kind of attacks are being happening. Okay, we have unauthorized internet access, sync flood, ping of death, smurf attack. So these are all related to kind of denial of service attacks that is going to happen at transport layer. Sync flood, as I told you, multiple syncs will be sent, okay, at transport layer. This like TCP syncs. TCP sync. Multiple TCP syncs are sent to that server, end up choking the bandwidth. Similarly, we can have access unauthorized internet access. We have Smurf attack, ping of death. You can read these all attacks. By the way, these all happen at transport layer. Then we have a session layer. The session layer manages the establishment and tearing down of connection, and we already talked about it. These connections could require authentication, authorization, session restoration, tokens etc to set up. During this process, it is possible for the session to hijack through man in the middle attack. So scenario is very simple. Let's suppose we have this computer device, we have this server, and of course we have one session created on the basis of cookies. But if some man in the middle person is sitting over here and he captures this information about the session or the cookies, so he can malfunction this information and can hijack that session. Okay. So the fundamentals of using secure socket layer and transport layer. So, the remedy is lies into SSL and TLS, transport socket layer, or also known as TLS as well, transport layer security. Similarly, the mitigation is SSH. If you remember, I talked about telnet. That is also one of the, the victim uh, of the high session layer hijack attacks. Somebody can uh, extract this clear text password and then he or she can create its own session. But the overcome and the mitigation lies into SSH, secure shell, which is going to encrypt all data. So if the sender and receiver is over here, they are going to form one session, secure shell. This is encrypted session, encrypted. So no matter how many data this hacker is going to capture, these all will be gibberish, encrypted data. He or she cannot decrypt data unless until he is having or she is having some formula. And to break that formula, you require so much high processing power. Okay, so Kerberos is also, so these things are the mitigation, and this is also IPsec security protocols. So before sender sender device is going to communicate with the receiver device, they are going to create one secure IPsec tunnel. Then data will be transmitted across this pipe and will reach to the destination. And if the hacker is going to capture, he is going to capture nothing but some encrypted data which they cannot understand. In the last, we have presentation layer. Sorry, we have one layer up, after that. So sixth layer is presentation layer. The presentation layer ensures that the communication passing through are in the appropriate form for the recipient. Some of the services as this layer are data conversion, character code translation, compression, encryption, and decryption. For example, the malformed SSL request. So this happens as presentation layer. Attackers could use SSL tunnel HTTP attached to target the server. Similarly, I have already talked about the SSL hijacking. So these all happens not only in the session layers as well, but at the presentation layer as well. So that is why application, presentation, and session layer are squeezed into one layer called application layer if we will talk about the TCP IP model. The OSI layer that we have talked about is the OSI layer, and opposed to OSI layer model we have TCP IP model where these all layers have squeezed into one layer called application layer. Last but not least, the application layer. So this is the application layer where I would say 80% of the targets or attacks happens, because this is where the end user interacting Maybe he is going to open an email received from a hacker, where it is most of the time it is written that you have won some prize. Okay, in order uh, to get that prize, kindly click on this link. So some URL kind of stuff is over here, and if you are not good uh, understanding the attacks, you will click that link. It will basically take you to the hacker malfunctioned website, which will be look like that this is real. Okay, basically hacker is going to fool you. So they will ask you, kindly provide your username, kindly provide your password. Maybe it will ask you to enter your this credit card information and something like blah blah blah, kind of thing. So these all things happens at the application layer. So let's read this paragraph. It's saying the application layer is the hardest to defend for several reasons. For a starter, the layer is the most accessible and the most exposed to the outside world through port 80, which is not clear. Sorry, which is not secure. Or the port HTTP3, which is HTTPS, which is secure, but still, there is a possibility hacker can hack this port as well. Secondly, it provides a service to application procedures that are located outside the OSI layer. According to the Gartner, and by the way, Gartner is a very good website that is going to give you, um, you know, uh, v- um, can say, going to give you a brief information about the attacks that is happening currently, maybe attacks happening in 2024, in 2023. Similarly, Gartner is going to give you information about um, one vendor versus another vendor. For example, if I will give you example of AWS versus Azure. Okay, so it is going to give you um, this versus kind of things. So Gartner is very good website if you want to go and just surf this website to take a look. So Gartner 70% of successful attacks occurred at this layer. I said 80%, but maybe these days we are um maybe 90% are attacks are being happened on application. But as per the Gartner, 70% successful attacks are being occurred at this layer. So what kind of those attacks are? As I said earlier, denial of service attacks. We have HTTP flooding attacks. We have SQL injections, because in username we have text box, we have password, we have text box, and we have one button to submit. If you are very good programmer, what if you are very good programmer and you what SQL injections are, you are going to put one SQL in query. You are going to inject that SQL query inside that username box, because at the end of day this query is going to reach database server and it will bring the uh, reply which hacker is interested in. So you can inject so many uh, SQL injection. Then we have cross site encrypting, authentication, access control. The remedy lies into cryptographic algorithms. Crypto is encrypting a data. For example, if the data is A, I'm going to encrypt into $1 2 x bj3 into this format. Are you going to understand what it is? Okay, so this is called cryptography. Then we have session management. We have some kind of viruses happens at application layer. We have worms, trojans, and phishing attacks. These all happens at application layer. So I hope you got a very good understanding about network attacks. So OSI layer from the perspective of cloud computing, I'm going to stop this video over here and I will join you in